Okay, time to do a little bit of vector stuff. We talked on Friday about absolute value and how really it's just Pythagorean theorem. So today I just want to add a couple more little pieces so that tomorrow when we finally get together again, we can move on and get into cross multiplying and dot multiplying. So today I'd like to talk about, just for a few minutes, multiplying a vector by a scalar. Okay, and that looks really blurry even to me. And so if we say let A be a vector and let, I don't know, let's say alpha, which is the Greek letter, be a scalar, then if I multiply these together and I get alpha A, then what I get is going to be a vector. Really what it's saying then is whenever I take a vector and multiply it by a number, then I'm going to get a vector, and I'm going to get a vector parallel to the original, so that B will be parallel to A. Well, that should make sense. If you think, if A is just some vector like this, that has some component in the x direction and some component in the y direction, and then I multiply it by 2, well, I'm just going to get B, which is going to be just right along A, only twice as long. So whenever I multiply a vector by a scalar, what I get out is a vector whose magnitude is parallel to the original vector that I was multiplying. So the magnitude of B, or I think maybe we don't write the arrowhead over the top. So the magnitude of B is just equal to alpha times the magnitude of A. Okay, so always, always, always parallel to the original vector. Okay? The same would be true if I were to divide. Obviously, if I divide by 2 instead of multiplying by 2, because that's the same as multiplying by 1/2, I'm still going to get a vector that's parallel to A, just half as long now instead of twice as long. So from that we can get something that's called a unit vector. Because what if I were to take A and divide it by a scalar that's actually the length of A? So if A was a vector that was 5 newtons going whatever angle, and I just divide it by 5, then what I'm going to be left with is a vector, but it's known as a unit vector. And the symbol, when a unit, because it just has a length of 1, a magnitude of 1, so really it's just the unit. And the symbol for a unit vector is n with a little cap over the top. So whenever you see this little cap, it means it's a unit. It means it has a length of only 1, no matter what direction it's in. Okay, so we can form a unit vector from almost anything. And we'll often talk about unit vectors in the x direction, the y direction, and the z direction. Okay? Because we then could break our vectors down into, like, so if this guy was 4 in the x direction and 3 in the y direction, then we could write this A as 4x, put a little cap there, plus 3y with a little cap. And so we could figure out, oh, then A is going to be a length of 5 because of the components. We could easily find its length. So instead of saying it's 5 at an angle of whatever, we can say, oh, it's 4 in the x direction and 3 in the y direction. And you'll often see it written like this, where these caps are really indicating unit vectors that we would find by simply dividing the vector by its length, by its absolute value. Okay? And so we could write then any vector, I'm going to write it as a capital A, we could write it as a component of A in the x direction, plus a component of A in the y direction, plus a component of A in the z direction. But if we were to use the unit vectors, then we could write it as A x hat, and we would drop the arrowhead over the A, plus A y hat plus A z hat to indicate that it's going in the x, the y, and the z. So that's often what was done, until they realized that having these x, y's, and z's sometimes were a little confusing, because we often use the x, y, and z's to indicate our variables. And so now to use them as unit vectors, it was getting confusing. So instead, when we talk about a unit vector in the x direction, we use I. And when we talk about a unit vector in the y direction, we use j. And when we talk about a unit vector in the z direction, we use k. And so here, instead of writing it as a x hat, we would write it as a I hat plus a j hat plus a k hat. Okay, and so it's just saying how much is it in the x direction, how much is it in the y direction, how much is it in the z direction. So up top there, that a that we had, we could write it as 4i plus 3j. And that's telling you it's going 4 in the I direction and 3 in the j direction. Okay, so if I draw something here, and I'm going to draw a vector, I'm going to make it -8 and +7. And so that means that this piece is 8, and this piece is 7, not necessarily drawn to scale. And so how would we write it? We would write it, let's call it B, we would write it as -8i plus 7j. Okay? And how about I'll do A over here. What was A? A was, oops, put an arrowhead over B. A, we had already said, was 4i plus 3j. And so when we go to add vectors, now it's really easy adding them this way. If I want you to find A plus B, then it's just 4i plus 3j. Whoops, that's not a j. Dyslexia. Plus -8i plus 7j. And so now to add, you just add up the i's, -4i, add up the j's, 10j. And so A plus B would just be equal to that. Okay, because really what we're doing is we're saving ourselves some time. Earlier, I would have told you that this was 5 newtons or whatever it was at an angle of, and you would have had to find the two components, and then you would have had to find the two components over here, and then you would have done exactly what we just did. But when we're using I, J, and K, it's actually, we already have the components. And then we can just add them or subtract them depending on if they're going in the same direction. We could find what is the length of this by then, right? Absolute value. In other words, Pythagorean theorem. And so it'll just be square root of -4 squared plus 10 squared. Okay? So easy, easy. So I believe that you could probably now do the first, I think it's 2 questions on your sheet that I gave you on Friday, the front side of your vector sheet. I'm saying I think it's the first 2 questions because I don't think I brought a copy of that sheet home with me. I brought home my notes and I forgot the sheet. So if one of you would just double check and let me know, that would be great. But so don't do dot multiplying, cross multiplying, or the angles. Just do the first couple. And tomorrow we'll get into the rest of the good stuff. Okay? Enjoy your day. Finish your math sheet. See you tomorrow.